Hello, you are welcome to Master T Masters. And here in this live class, we want to look at this topic in mathematics, which is longitude and latitude. And this has to do with the geometry of the Earth, that is Earth geometry. So, which is longitude and latitude. And these are what we want to consider in this class. And we should be able to recognize the first one, recognize the Earth as a sphere. So the Earth is a sphere and not a circle. So that is the first thing that we need to recognize. And also the second thing that we need to know here is to be able to identify the great in small circle. So we call something great in small circles on the Earth. So we should be able to recognize that in this class. And also we should be able to define and differentiate between latitude and longitude. So when we see lines on the surface of the Earth, we should be able to differentiate between the lines, know which one is latitude and know which one is longitude. All right. So next, which is important, is you calculate distance or calculate distances on the Earth's surface along lines of latitude and also along line of longitude. So we should be able to calculate. We are going to be calculating what is called the angular difference or the angular distance. So we call something angular distance. So we will be able to calculate the angular distance and also distance between 2 points on the Earth surface. Distance between 2 points on the Earth's surface. And before this, what is important is that also, even before we calculate distance between 2 points, we should be able to locate places on the Earth surface. So this is very important. When a place is given, let's say point A is given as 60° north, 40° west. How to place this position of A on the Earth surface is equally important. Do well to stay tuned to the end of this class, and so that you will be gaining maximally from this class of longitude and latitude. So as you are watching, try to give us a thumbs up and share this video, and also subscribe if you are just joining us for the first time. And thank you for doing that. Now let's go proper into what we have. The first thing here is that we'll be looking at the first subtopic here, which we have. That is, we want to recognize the Earth as a sphere. So to recognize the Earth as a sphere, so a sphere is not a circle. A sphere is different from a circle. So that is why whenever we are working on longitude and latitude, we don't have to use compass to draw the circle. So just use your freehand sketch to draw the Earth surface. So we have this Earth as a sphere. So it's a sphere. That means, when you have a sphere, something like your orange, so it's a sphere. And one important thing that we should know, that the photograph of the Earth taken is making us to see the Earth as a sphere, which has a radius. The radius of the Earth, radius r of the Earth, is discovered to be approximately 6,400 kilometers. So this is the radius of the Earth. And the Earth here has a line passing through the center of the Earth. This line passes through the center, and this line is called polar axis. So these are parts of the Earth that we should be familiar with. So this is called the polar axis. This is polar axis. And also up here, we have the North Pole, and here we have the South Pole. You know, just like whenever you have your cardinal points on bearing and distance, so you are going to have this as north, this as south, this as west, this as what? East. Okay? So the same way here, we have this as the North Pole, the South Pole, and very close to the origin here, we have a line of reference, and that line of reference is the line of reference to all latitude. So here we call something equator. So equator here is a latitude of 0 degree. So we have equator and is of latitude 0 degree here. So that's the reference to all latitude. So it means, in other words, that line of latitude are horizontal. So we are already defining what latitude is now. Okay. So all horizontal line on the surface of the Earth are all line of latitude. So that is why if we draw another latitude towards the north like this, it will be latitude towards the north, and a line also horizontal here will be latitude towards the south. And this line of latitude ranges from 0 degree to 90 degree north. Okay, we get there. Let's look at something here first. And we also have a reference line here, very close to this polar axis. So this line also is the reference point for all longitude. And this is called the Greenwich meridian. Greenwich meridian. Greenwich meridian, which is shortened as GM. And the GM, Greenwich meridian GM, is same thing as longitude 0 degree. So that's the reference point to all line of longitude. So these are what we should identify on the surface of the Earth. We have the polar axis, we have the equator, that is latitude 0 degree, and we have the Greenwich meridian GM, which is longitude 0 degree. Now, it means, okay, as I've said earlier, if we have a line like this up here, this line is a latitude. Latitude, line of latitude, latitude north of the equator. This is latitude north of equator. All right. And if I have it this way, this means we have latitude south of equator. All right. So this horizontal line, their latitude. So when we have it towards the north, is latitude towards the north. So, and the degree might be given. This here might be 40 degree north. 40 degree north. Just note that latitude ranges, line of latitude ranges from 90 degree north to 90 degrees south. So what we mean by this is that from the 0 here, and when we are going to the north, the maximum we can reach is 90 degree north. And going towards the south also, the maximum we can reach towards the south here is also 90 degrees south. So that is that. And for longitude, This is towards the west, and this side is towards the east. So any line of longitude drawn towards here is called longitude west of GM. This is longitude west of Greenwich meridian. And if we draw another one on this side, this is called the longitude east of the GM. And this line of longitude ranges from the 0 here, the maximum we can reach here is 180 degree. So for the line of longitude, we can have maximum of 180 degree west and also maximum of 180 degree east. So that's the fundamental of the Earth surface. So once we are able to identify all this about the Earth surface, then the next thing is to know which one is a great circle and which one is a small circle. So as part of the agenda we are looking at here, so we should recognize what great circles are, great circles and also what small circles are. Now, looking at the diagram we have, great circle, because all this line we draw, it's like they are circle, all right? It's not just a line, it's like a circle. Like for instance, now this we have, a duplicate at the other side, just like this equator now. So, it's a sphere, all right? So when we, like, as you are slicing your orange, it's forming each of the slices. You cut it, it will form a circle. So like we have this now, it has an image. Also this one has, like, but for us to have a clean shape here, that's why we are not drawing this. All right, now looking at this, we define great circle as the line of longitude. So all line of longitude are great circle. They are great circle. All line of longitude are great circle. So that's the first one. So great circle, all lines of longitude are great circle. And small circle, all lines of latitude, are small circle. Okay, now we still have a line that's also a great circle, but it's not a longitude, and that line is the equator. So equator is also a great circle. Equator is latitude 0 degree. That's the only exception that is not a small circle. So latitude 0 degree is therefore a great circle. So great circle is also, so here we just have just one. For great circle, equator is also a great circle. Equator, which is latitude 0 degree, is also a great circle. So we have all these fundamental about our longitude and latitude, which is the x surface. So we should understand that the radius of the Earth is approximately given as 6,400 kilometers, and we recognize something called the polar axis here. That is this line that passes through the center, and we understand and we identify what is called the equator. That is the latitude 0 degree, which is very close to the center, and also we identify the longitude 0 degree, which is GM, also very close to the center, and all other lines of latitude and also longitude. So you are watching us here live at Master T Math class, and thank you for joining us. Why not give your thumbs up, share this video, and also subscribe. Now let's move on to the next thing here, which is finding the angular distance, okay, between two places. But before then, something is very important. Let's look at that. Locating places on the Earth surface. So that's should be the next agenda now. Let's try and locate places. So locating places on the Earth surface. So here we should be able to locate places on the Earth, on the surface of the Earth. When we are given points, you should be able to locate it. Now let's look at this following point. Sketch the position of the following places on the Earth surface. So as an example now, sketch the position of the following places on the Earth surface. On the Earth surface. Now let's look at those places here. The first one we have point A, 15 degree north, 30 degree west. 15 degree north and 30 degree west. And this point is called point A. And 2, we have point B, and that is called 15 degree north, 45 degree east. 15 degree north, 45 degree east. And 3, we have point C, which is given as 0 degree and 30 degree west. 0 degree and 30 degree west. And number 4, we have point D, which is 0 degree and 45 degree east. 45 degree east. And also we have point F. That's number 5. Point F. That's given as 65 degrees south, 65 degrees south, and 45 degree east. So here we want to sketch the position of these places on the Earth surface. We're just going to use just one diagram for all these places. So we are going to recognize those places on the Earth surface. So first thing is to draw the Earth surface. Just use your free hand sketch, not compass, because here the Earth is a sphere, it's not a circle. So that's why we are not using compass to draw. And you know, when after you draw the Earth surface like this, you can, there are some places that are very important for us to recognize. So the center, we have the polar axis that pass through the center of the Earth. So you locate the center and you draw this polar axis. This is North Pole, this is South Pole. Where we have the west side, we have the east side. All right. So we have to do some things like this as point of reference. And next thing is to draw close to the center here. We have something called the equator. So we draw a line which is very close to the center. That's the equator. which is the reference to all line of latitude. So here we have this line as equator, also known as latitude 0°, and also close to the polar axis as well, we draw a vertical line, and this line is called GM, Greenwich Meridian, which is longitude 0°. Now, we can locate these places now, but before we continue to locate places, something important should be noted here. As far as latitude, longitude, and latitude is concerned, there is something important. When we are working in Cartesian plane, we call something ordered pair. Ordered pair in Cartesian plane, and for that, our ordered pair is always x before y, so x comma y, right? And also here for latitude and longitude, our ordered pair is always written as latitude comma longitude. So all this one we have here, we want to interpret it. The first point here is the first angle here is angle of latitude. That is latitude, then longitude. And the second is longitude. Also here, latitude, longitude, latitude, longitude, latitude, longitude, latitude, longitude. So we must write latitude first before we write longitude. So that is for latitude and longitude. And we understand that latitude are horizontal line. Latitude are horizontal line, while longitude are what? A vertical line. So it is easier now to be able to draw whatever we want to draw. Now let's locate point A now. It means 15° north latitude. That's horizontal line towards the north. And we are not measuring here, it's just a sketch. We established that the maximum we can reach is 90°, and it is 15° we want to measure, right? So it will just be a little bit far from the origin. So 15°, we locate it this way, and we call this as 15° north. So the reason why we draw it up here is because it is north. So it will be towards the north. Latitude 15° north. Then longitude 30° west. And this is a western part. This is the eastern part. So west here, it will be vertical line towards the west. And also that we established that here, the maximum we can get to here is 180. And since we are given 30°, just a sketch. So just draw a vertical line as this and label it. Might be on this side. Might label it on this side as our longitude 30° west. Now, something important here. Look at it. We plotted this. That's 15° north. We plotted it 30° west. Now, those two lines meet at a point. That is this line and this line. They are meeting here. So where they are meeting now is our point A on this surface of the earth. So that is how to locate places on the surface of the earth. So in the same manner, we are going to locate point B as well. And for point B, the latitude is 15° north, and which we have drawn before. So we have 15° north already drawn, and the longitude 45° east. That means it will be on the east part now. So vertical line 45° is just a sketch. So we draw the 45° this way, and we can label it as 45° east. That's longitude. All right, 45° east. Now, where 15° north and 45° east are intersecting here, that is our point B. Okay, so we have located point A and B. Now, point C is 0°, 30° west. This 0° here, the first one we share is latitude, and the one that is 0° is equator. Latitude 0° is equator. So this has already been drawn as the equator, which is latitude 0°, and also 30° west. We have it already. We draw it already. So where 30° west and the equator meet is our point C. So that's how to locate places on their surface. Then also locate point D now. If I ask somebody to locate it now, easily we are going to see that. How? Because 0°, that's the equator, that's latitude 0°, and 45° has been drawn. This is 45°. So where these 2 points meet here, that's our point D. Okay? Then in the same way, point F. Okay, I think I join point E. So there is E before F. So let me write it here. There is point E. And that point E, we are given at 65° south, 65° south, 0°. And here, 65° south here, this one here is line of latitude, okay? Because the first one is latitude first, before what? Longitude. So 65° south, 65° south. So we are going to draw it on this side. It's a sketch. The maximum we can get to is 90°. So towards the south now, 65° south. We can label this as 65° south. That's latitude. Then longitude 0°. And which one is longitude 0°? That's our Greenwich meridian. This line. So where 65° south intersects with Greenwich meridian, which is longitude 0°, here, where they intersect, that's our point E. Okay? Then now let's look at point F. Point F is 65° south. We have already drawn that. Yeah, 65° south and 45° east. And this here is 45° east. So where they meet here, that's our point F. So I believe with this, we can locate places on the Earth surface. So you are still watching us live at Master Tima's class. So stay tuned to the end of this class, and also give a thumbs up and share this video so that to reach more audience. And thank you for sharing. Now, next, we'll be calculating the angular difference between 2 points. Angular difference So we have something called angular difference, or sometimes call it angular distance. So it might be called angular difference or angular distance. Now, first, on the same longitude, angular distance on the same longitude. That's the first thing. Angular difference on the same longitude. And when you say longitude, what we reverse to as great circle. So all line of longitude are great circle. So let's consider this angular difference on great circle on the same longitude. Now, for example, find the angular distance between the following pairs of points on the Earth surface. Example now. Find the angular difference between the following points, the following pairs of points on the Earth's surface. Now, let's consider two of it. The first one, we have points E, 30° north, 45° east. Point E, 30° north, 45° east. And also point F, 25° south, 45° east. 25° south, 45° east. Then the second one as well, we have G, 70° north, 35°. Okay, point G, that's 70° north, 35° west. Then H, 40° north, 40° north, 35° west. Now we have these two pairs of points and we are finding the angular difference between them. Now let's consider the first one here. When you look at that, these 2 points given here, they lie on the same longitude because this second angle here is the longitude, right? So that means they have these points E and F will fall on the same longitude, 45°. Now we can see that from the sketch. When we sketch this diagram very quickly here, very quickly have the polar axis here, which passes through the center. We have the equator, which are reference for latitude. This lat 0°, and we have the GM. This is longitude 0°. That's GM, and we can sketch this point now. That's 30° north. Don't forget this is North Pole, South Pole, West, East. And by the time we sketch this is 30° north. This will be towards the north, 30°. Here, and label this as 30° north and 45° east. Don't forget the eastern part is this side, right? So 45° east, just a sketch. Label this as 45° east. So where these 2 points, 30° north and 45° east meet, we can call it our point E. All right. And also here, point F is 25° south. South is latitude, right? The first point is latitude. So it's toward the south. So we can sketch it and we call this as 25° south here. And also 45° east. So also line on this line of 45°, where they meet here, we have point, what is it called? F. Now we can see here that both E and F, they fall on the same longitude. That is, they are on the same great circle. Now, we want to find the angular distance between points E and F. Now, something interesting here now. We are going to draw something here. This is center hole of the Earth, and this is a reference point to the latitude. So, we have a radius here already. radius, and we still have this radius here from point E to the center, and we have the angle between this here now is 30 degree, right? And also we sketch this, that's from point O to this place, and the angle between here is 25 degrees. Now we are now finding the angle between E and F. We discover that is together like this, E and F. So that means the angular distance or the angular difference between point E and F will now be equals to 30 degrees plus 25 degrees. Okay. So it's the total angle here that we are going to add together now. So that means angular difference or angular distance now is now equals to 30 degrees plus 25 degrees, and that is equals to 55 degrees. Now, because there are sometimes all we just need to do is to get this angular difference and use it to solve a particular problem. So we don't have to be sketching and seeing it before we can decide the angular difference, offhand. Offhand. Something interesting is here now. This one we added these two angles here, 30 degree and 45 degree. Sorry, 30 degree and 25 degree. Now, consider these 2 points. Since they both lie on the same longitude, that's a shortcut now. Since they both lie on the same longitude, which is 45 degrees, 45 degrees, now that's the reference point. We are now going to consider here, this angle are not the same thing now. This one is 30 degree north, this one is what? 25 degrees south. This is towards the north, and this is towards the what? South. Different direction, okay? Which means for different direction, it will be what? Addition. Okay, now this is 30 degree north, 25 degrees south. Consider this north, this what? South. This is towards the north and this is towards the south. Different direction, right? So the angular distance now along this line of longitude will just be 30 degrees plus 25 degrees. So that is the shortcut. Now, even without drawing the diagram for this one yet, we can still tell us the shortcut. This is also on the same longitude, right? 35 degree west, 35 degree west. They both lies on the same longitude. And now we consider their latitude. This is 70 degree north, 40 degree north. Different number, but the same direction. They are both on the same direction, north, north. So when we have same direction, their angular distance will be subtraction of the latitude. So that means for this one, angular difference will be 70 degree minus 40 degree. So we can still check it out by sketching the diagram to see. So that is it. So the angular distance will be subtraction. So let's look at that here and see. On the second one, so we have this as the earth surface. We can quickly sketch these 2 points to see what we are talking about. This is the polar axis. And this is center. This here is the equator. This Greenwich meridian, which is lat 0 degree. This is longitude 0 degree. and this is north, this is south. So let's sketch what we have. Point G here. Okay, this is west, this is east. So we have 70-degree north here. 70-degree. Yeah, it will be closer to the top here. So let's call this 70-degree north and 35-degree west. 35-degree west. Towards the west here, we have 35-degree west. Then also here, where they meet is our point G here. And also point H. That one is 40-degree north. So it's also towards the north, but it won't get to 70 degrees. So 40 degree, we can call it somewhere like this. This 40-degree north. And here we have 35-degree west, same longitude. So here we have point H. Okay. Now, to get the angular distance, now don't forget that here, of course, we have the center here, right? So if we draw this as the radius to the center from the equator, and here we have this here. This angle from here to here is expected to be 40 degree. Okay, and again, we assign for the center as well, getting to this point here. When we draw this as well to this side, it's the 70 degree now also comes from this reference point here. So this also from here to here now is everything total to what? 70 degree. Okay. Now, but I believe you can see this in a way clearly. So this here is 40. This here is what? 70 from this same point. And the angular distance we are finding is between point G and H, which is only this angle here. All right. Now, if we want to get only this angle, and everything here is 70, here is 40, what do you think we do there? So this angle here, which is between G and F, will just be 70 degree minus 40 degree. And that's what? 30 degree. Can you now see that we subtracted? So that's subtraction of these two angles. That will be 70 minus 40. So it means that when they are on the same direction, not north, or it might be south-south. So same direction, we subtract. But here we have different direction, we did what? We added. So that is that. I believe we should stop here in this class with this. So when we meet next class, we continue from here. Why not be part of us? Share this video, give it a thumbs up, and subscribe. And thank you. See you next class, and bye for now.